All right, let's talk about work. So work is just a force vector that pushes some object over a displacement r vector. Or you could write this as the magnitude of that force times the magnitude of the displacement over which the object moved that the force was pushing on times cosine of the angle between these two vectors. So, for example, let's say you have some box sitting on the ground and you push on the box with 3 newtons and then you push it and it goes all the way over here so that it's gone, let's say, 10 meters. So what's the work done here? Well, the magnitude of the force was just 3 newtons, that's this, and then the displacement magnitude was 10 meters. And then what's cosine of theta? Well, what I like to do is draw the two arrows of the force and the displacement tail to tail, and then look at the angle between them. Well, these two are going in the same direction, so theta equals 0, and that means cosine of theta is cosine of 0, which equals 1, so this is just times 1, and that's equal to 30 Newton meters. Okay, so let's look at a different example. Let's say instead now you have the ground and your block, but you're pushing down at an angle of 40 from the horizontal, and now you move a distance of, say, 8 meters to over here. So now what's the work? Well, and let's say that you're pushing with 5 newtons. That means that the magnitude of your force, so work is equal to, again, magnitude of the force, which is equal to 5 newtons, times how far you went, 8 meters, and then now times the angle between them. So what's the angle between them? So again, draw them tail to tail. So we have displacement vector, have the force vector, and the angle between them is just 40 degrees because this one is along the horizontal. So just like this was 40 from the horizontal, this will be 40 degrees between the force vector and the displacement vector. So that's times cosine of 40. So that's work, and I hope it's helpful.